welcome to another episode of Papa's Workshop. These are for Adam, Brady, Luke, and Brenna. Here we are, another week into this virus thing. Today we're going to talk about routers. Let's see our assistant first, though. She is guarding the floor. Yes, there's a little treat for you. She loves her treats. Big brave guard dog is afraid of thunder, and we got a thunderstorm coming. So she's a little nervous. She kind of senses them when they're coming, don't you? Yeah. You just take a nap there. We're going to talk about routers with them. A router is really nothing more than a motor that has what they call a collet to hold your bits. Let's just right there, and you notice that's got a profile on it, very much like this molding plane. Say they're very similar. So you can do what this molding plane does with the right or similar bit. You can do the same kind of cuts, but you notice it has a bearing at the top, and that will follow the edge of the board. So you can do curved cuts. So here's a piece with a curve on it, and you take that, and that bearing will follow that curve, and you'll get a profile like this. And you can see this actually has I used a second bit on this bottom part. See where it ends right here? So I combined two bits. You can't always do that. It's kind of tricky. The router bits don't work like the hollow and rounds. The molding plane hollow and rounds were, I think it's like 1/6 of an arc, whereas these, you can get hollow and round bits, so to speak, like this, but you notice they're 90 degrees. The hollow and rounds were only a portion of that. See, they're only a portion of that arc. They're not the whole arc. So it allows you to blend the curves in, whereas this, you've got to end exactly at the point. And then you got the bearings. You've got to be able to work that in there. So it doesn't always work to mix and match, but it's very useful. You can do here's the tongue and groove, like we did on the tongue and groove molding planes. You can do dovetails. You get different size dovetail bits. You notice the bits come in two different bases. This big router takes these 1/2 inch bits, but it'll also take these 1/4 inch, the diameter, and that goes in this smaller router. We'll talk about that in a minute. You see, this one's a beading bit, just like the beading molding planes. You can do, here's a pretty involved one, and that kind of looks like this. See, that matches right up. This was what I did the kitchen in, is with these two bits, and that's ends up with here's a prototype of the kitchen doors, and you can see that profile right there is that bit. These bigger bits like this one, you have to use in a router table, which we'll talk about in a minute. But if you're doing a raised, this is called a raised panel, where this in the center is raised up. You've got to use a big bit like this to hollow that out. You notice these have a mitered corners as well, and that's done with again, you can use the router to do mortise and tendon. So there's the mortise. Mortise is a hole. Usually, traditionally, that's just more of a rectangular hole than a rounded ended. In this particular case, it's called a floating tendon because both pieces have the mortise. You put this little floating tendon in, and that makes the strong joint because you're gluing. The glue does not stick to the end grains. It's the end of the straws, right? There's nothing really there for it to hold on to. But what you get, the long grain of this board and long grain of the tendon, that becomes a very strong glue joint when you do this. And that's what all those kitchen doors were done with. And that frame and panel, so this is just a corner, but that big bit would do the panel, and then it would slip into the slots like so. And one of the things that the router can do that would be difficult, if not impossible to do with the hand tools, is it's a coping. See where you've got this profile here, you see it's on the end of the board as well. See it? I don't know if you can see it right there. So it goes all the way through. So what that looks like, you see you get that profile and this profile, and they just fit right together if you're coordinated. There, see? And that is a matched set of bits again that just fit right together. So you do one end with one bit and one end with the other bit. So that makes a quick, strong door joint. Traditionally, so that's what this was done with. Traditionally, you would have had to do mortise and tendon. This is a very short tendon. Normally, it would be a longer tendon. And then you see this little molding profile is mitered, right? So it's mitered to fit. And sometimes that molding would be applied afterwards as a separate piece of wood. That's how they would have traditionally done the doors. And the mortise and tenon is actually more is stronger than that other, but what they do is suffice. Like I said, the bits come in all sorts of sizes. You can get straight ones with bearings or straight ones without bearings, different sizes. You can do the rabbet cuts with this bit here. It actually comes with different bearings that I can replace and change the depth of the rabbet. I've got the dovetail bits. I think I did that one already. And like I said, the routers come into different sizes. This is called a trim router. And it just uses the 1/4 inch bit. This is a plunge base. And by plunge means I push down and I can change the depth of it with this rod right here. Whereas this base here is a fixed. So I put this on like this, and that becomes my adjustment. And put this in there like so. And now when I turn this, you can see that raises and lowers, but that's now fixed. When I lock that in place, the height is fixed. Whereas this one, I can go over something and then plunge down into a hole. Now, this one you can't do that. This is, you can go around the outside. This one has a place for a vacuum to collect the dust. Sometimes that's not, if the dust has another way out, the vacuum doesn't always get it. This one doesn't have that, neither does this trim. One thing we should probably mention is the safety with these. First off, they're very noisy, so got to wear hearing protection, and they kick out a lot of debris. You need to wear eye protection, maybe even a dust mask when it's they also you gotta know which way to move the router. The bit moves in a clockwise direction, and so if your piece is out here, if you just push that up against that, it's just like a toy car. That wheel is going to want to push the router this way. I mean, it's just going to take it right out of your hands. So if you try to go that way, you're going to have a hard time guiding it because it's going to want to go that way. So you actually move the router this way. You want that resistance to go around. So you would keep going. If you were going around the whole board, you would keep going around in that direction, all the way around the board. It's the reverse on the router table, which we'll get to in a moment. So you got to be careful of that. You got to realize that safety part of it. But they are very useful tools. You can use templates. Like here's just a simple template. I could take some double-sided tape and tape that down to a board, and I would then cut the corners off with a handsaw to remove some of the, most of the material. And then you could use any one of these bits that has a bearing on it. How to do that? And the bearing would follow the template. So I'd end up with whatever my shape is on the template on the board exactly. That's very useful. I did the kitchen drawer sides with this. I mean, it's just whatever shape you want to use. Remember the marble boards I made? This is a prototype of the marble boards. This is done entirely with the router. I start out with the square blank of boards, bigger than this circle. I then would screw this down on the corners, because the corners are going to be cut off later. I would take a router and follow this profile, and then use the router to cut out all the middle down to a certain depth. And once that's done, I would take this and put it in that recess that I created with that star, and that gives you all the holes. Using this is a bushing. This is a different router base, but you see it's got that little raised bushing, and you can get, there's the set. So you got all different sizes of those bushings, and then the bit would stick up through that, but that that bushing, it would follow a template. And so for this, I get the right size bushing that fits in that hole. I use the plunge router and a pointed bit to make all the marble holes. Then I use a compass. I take this attachment here, attached to the bottom of the router, and this got this little pin. So I put that in the center hole while it's mounted on my blank, right? Like this. And then you spin the router around and make the hole outside that way. So it's done entirely with the router. So the possibilities are pretty much endless. You just have to either make or buy all of these attachments. You can get a fence. This came with the router, and it goes into it this way. So you can do the rabbits or dados with the fence. The dados you can do with the flat bits. You can, just like on the molding planes or the rabbit planes, or excuse me, the dado planes, you can clamp a board going across the grain and follow it. But you can also, with a router, you can put two boards with a smaller bit, go that, and then go back down the other way, and you can, make any kind of width you want. You don't necessarily have to have a bit that's the width of the dado that you want. So anything you can do with those molding planes, you can do with the router. It usually involves more setup. That's probably the negative, is the noise, the sawdust it kicks up, the setups, and you've got to do trial cuts. So if you're doing one of something, it's a lot of times it's faster to do it with a hand tool. But especially if you're doing something like a kitchen, cabinets, a whole set of them, there's no way that this beats the hand tools hand down. So let's move over to the router table. Okay, this is my router table. What's different about the router table, like I said, the router's mounted underneath. So the first thing is that the bit's going in the opposite direction because it's upside down. It's going this way. So with your fence out here, you want to push your wood this way, right? Because it's going to try to push your piece out. So you want to go against the way it's pushing. If you went this other way, it's going to try to race that piece right out from under you. So you have to keep that in mind. So if you're doing it freehand without the fence, you're doing something. If you're going on this side of the bit, you got to be going this way. So this way or this way. So you got to keep in mind which direction it's going in. What makes the table nice is this fence. This particular fence, I can adjust it very precisely. But you really don't need a fence this fancy. It really could just be any kind of board. I could take this board and just clamp it down, and that's my fence. I can put a little notch so that it doesn't have to be straight. And, I can do it because it's a circular bit. Fence doesn't have to be square to anything. In fact, if I have to do a really long piece, I'll move this whole fence about like this, so I can go the whole length of things. So it doesn't have to be fancy. This one I use the router itself as the mechanism to lower and raise it. You can get lifts that you can crank up above and don't ever have to get inside of it. It's very useful, and like I said, this is what you use for those big bits. I can take these little yellow pieces out, and in this case I've got different sizes of them. But if you're using those big bits, you need a big router first off to be able to handle that power, and then you've got to have the hole for it. And the other thing is that they're all variable speed, or most of them are anyway, I guess. I don't think you can buy a fixed speed anymore. So the bigger the bit gets, the slower it needs to go. And they give you speed recommendations. But if this is the center of the bit, the speed that it takes to get to this point, this has to travel on the outside of the bit, has to travel that much farther, right, from here to there in the same amount of time. So the outside of it's going faster. So if you get the bigger the bit, so if we got a bit out here, that's going even faster with the same amount of rotation. That's actually going faster. That's why you have to slow it down, so that the outside of the bit is going at a reasonable speed. If you go too fast, the bit can fly apart, or you burn the wood. They're designed to cut at a certain speed, so it depends on the diameter what the speed actually what the speed setting is on the router. That's true of the table or in the mobile bases. I think that about does it. Oh, these are for holding. You're going to hold the wood. You got it up against the fence. You can go right there, but you use these. You don't get your hands within the 3 inches, right? And you're wearing your hearing and eye protection. I think that about does it for routers. We miss seeing you guys. Hopefully we can get together soon. Have a good one.